Hello, ladies and gentlemen. This is a question on applications of differentiation with regards to rate of change. This is a question from Darling High, 2017, which is an integrated program question. There is no scaffolding in this question, which makes this question slightly more challenging. Now, let's look at the question. The question objective is for us to find out the rate of change of the water level when the depth of the water is 4. So, your objective, you want to find dH over dt when head of the water is 4. Now looking at this, I'm introducing my own variable h, which is not in the question. So I'm just going to add the water level onto the diagram for you to visualize that. This h here represents the water. Now bear in mind that the container is fixed, it doesn't move. What is the variable here is actually the water. So looking at the container, I do not only need the height of the water, I also need the base, the square base of the water, which I'll put it as x. So let me just draw out a big triangle which represents the container, which I have 6 here for the sides of the square base, which I have 10 here for the height of the container. On top of that, I'm going to put in another smaller triangle in blue to represent the water level. So the height of the water is h. The square base sides of the water is x. Because the two triangles are similar, therefore the ratio of the corresponding sides are equal as well. So I can form the ratio x over h is equal to 6 over 10. With that, I go back to the question. Water flows into the vessel at a rate of 10 cm cubed per second. So therefore, dV over dt is 10 cm cubed per second. So in this case, you want to find dH over dt. You are given dV over dt. So think about what should you have in order to form dH over dt. So you want dH, so you have a dH there. You want to get rid of dV, so you have a dV here. Now, this is a hint for you to form an equation with V and H. Now, bear in mind that this V and H here are both talking about water, not container. So, volume of water, height of water, which you know that the water follows the shape of the container, which is a inverted right pyramid. So therefore, the volume of the water, which is 1/3 square base, which is x squared, times the height of the water. Now in this case, looking at the equation that you have to form, there is no x involved. So therefore, you have to get rid of the x, which is also one of the variable. And that's when this will help you, because you can simply make x a subject and therefore substitute into the volume of the water that you have, and therefore simplify it further. There you go. You will be having 25 over here, and you will have 3h cubed. Okay, so now you will perform differentiation on this dv over dh, which allows you to have 9h squared over 25, which then, looking at your objective, dh over dt is equals to dv over dt, which is the information 10 times. Now take note, this is something that you need to take note as well. The question wanted dH over dV, dH over dV. You have dV over dH. Therefore, you have to flip, which is 25 in the numerator, 9h squared in the denominator. So now substitute your h equals to 4 into the equation. So with that, I believe you can calculate the final answer by yourself. And the unit, don't forget, will be cm per second. That's all from me today.